Hi, in the last lesson we were looking at this collection of geological materials and trying to sort them out, trying to group them into groups that have similar features. Now, I'm sure you've come up with your own way of doing this, but geologists have a specific way of dealing with each of these. We put them into one of 5 different geological groups. Let's have a look at the answers to this practical activity, just so you're aware of what these things should be, and perhaps more importantly, how we as geologists would start to go about organising this particular group of materials. Now, the 5 groups that I talked about last time are minerals, igneous rocks, sedimentary rocks, metamorphic rocks, and fossils. You should have a table at the top of page 3 that looks a bit like this. Let me show you the answers to this, and then I'll go through what it is about these materials that allows us to group them this way. Don't worry if you got some of these wrong. This isn't an easy thing to do, especially when you first start geology. It's something that will come far more easily with the practice you're going to get through the course. Okay. Specimen J and specimen M were both minerals. We call these minerals mica, so J is mica, and M is a mineral called pyrite, or perhaps more commonly known as fool's gold. Write these down for now, and like I say, I'll go through why they are in a moment. Okay, the igneous rocks, specimens P, W, and Z are all igneous rocks. So this is gabbro, granite, and dolerite. Each of these are different types of igneous rocks. The sedimentary rocks, there were 3 of them. Specimen A is a sedimentary rock called conglomerate. Specimen E is a limestone, but we describe it as being fossiliferous because it had fossils in it. V is a shale, and that contained plant fossils. The metamorphic rocks then, there were 2. Specimen H is a rock that we call gneiss. It's spelt slightly differently, but we call it gneiss, the source of much geological humour. And specimen U, which is slate. And finally then, the fossils. I only gave you one fossil, specimen B, which is a coral. So those are our geological materials, sorted out in the way that a geologist would do it. Now, the reason we split them up like this is because of how they form. Geologists organise materials by the way in which they actually form. So we need to understand how these rocks actually, are made to then be able to interpret them. That's why we split them up into these particular groups. Let me talk you through them sort of one by one. So we start with the minerals. So we had specimen J and specimen M. These are minerals because they're uniform throughout. It's the same stuff all the way through each of these specimens. Both of these had their own key distinctive features as well that allows us to identify those. There'll be more about that in theme 3. But J was this sort of very flaky material, and M had these sort of goldy yellow crystals within it. The igneous rocks then, specimen Z specimen P, and specimen W. These three rocks all have in common the fact that they have crystals within them, and those crystals are interlocking. They've grown into each other. As the magma that they all formed from started to freeze, the crystals that grew locked it together to create this very distinctive igneous pattern. We don't see any gaps in it. The rocks are very, very crystalline. The sedimentary rocks in this collection, specimen A, specimen E, and specimen V, are a little bit trickier. Sedimentary rocks are recycled rock. They were something else and they've been eroded, transported and dropped down somewhere else. Now it's very easy to see that in specimen A. You can see big round pebbles that have been stuck together to make specimen A. It's a key feature of this rock we call conglomerate. E is a little trickier, but there are fossils within it. The only type of rock that we find fossils in is sedimentary. The hardest of all perhaps is V. Shales we don't see the fragments of rock that stick this together. They're too small. There is a plant fossil within this rock, which does tell us it's definitely sedimentary. But these sort of dark in colour, fine grain rocks can be really tricky. It's something we need to get some practice at, particularly thinking about where these rocks come from. The two metamorphic rocks, gneiss, which is specimen H, and slate, which is specimen U, both have alignment in common. The minerals within this rock are aligned. It's why the slate will split into parallel sheets to make it so useful for roofing. It's why the gneiss and H, you can see bands of different coloured minerals within that, because those different coloured minerals have been aligned. Both of these are a result of the pressure that these rocks have been under. There have been different amounts of temperature as well. H, for example, has been formed at a much higher temperature, maybe 700 degrees, than specimen U, slate, which may only be formed at maybe 250 degrees. Finally then, we have the fossil. I only gave you one fossil in this collection. This is specimen B. This is an example of a fossil coral. And fossils are formed by organic things. They're remnants of living things. So we look for organic forms within it, the type of patterns that we get that grow with the organism. Again, we'll get used to identifying the groups of fossils that are part of your course. Okay, we can see from this that there are lots of different geological materials, each of which have their own distinctive features, and it's really important to get some practice at understanding how these things form, so we can start to get more and more familiar with reading these rocks and minerals and fossils to get the clues about how they form. We are going to spend a lot of time on this. We're going to get a lot more practice at this, but I think that's probably enough for today's lesson. Next time, we need to start thinking about how we'd actually apply this to some other materials. I'll see you then.